Hi, hello, my dear students. Welcome to Mass Physics-Mnr. So, students, today topic name is chemical equilibrium acids and bases. So, students, weightage 4 and 2 marks. So, first one explanation. What is Lee-Chatelier principle? Explain the factors which influence of equilibrium. So, first one, Lee-Chatelier principle definition is explain. Lee-Chatelier principle. If a chemical equilibrium is subjected to change in temperature, pressure, concentration, that equilibrium is shifted to reduced or nullified. So, students, what is Lee-Chatelier principle? If a chemical equilibrium is subjected to change in temperature, pressure, concentration, that equilibrium is shifted to reduced or nullified. That is Lee-Chatelier principle. So, which factor? It is given different types of factor. First one, effect of concentration. Second one, effect of temperature. Third one, effect of pressure. Fourth one, effect of catalyst. So, students, four factors are influencing on the Lee-Chatelier principle. First one, effect of concentration, increases the concentration of reactant or decreases the concentration of product, that is forward reaction, opposite backward reaction. So, student, increases the concentration of reactant or decreases the concentration of product, increases the concentration of reactant, decreases the concentration of product, forward reaction is takes place. So, opposite, that is known as backward reaction. So, next one, students, temperature increases, endothermic reaction is favorable. Next one, temperature decreases, exothermic reaction is favorable. Next one, effect of pressure, number of moles are unequal. So, number of moles are equal, pressure is not affected. Pressure is not affected when number of moles are unequal. Number of moles are unequal, pressure is affected. So, students, number of moles are equal, pressure is not affected, that equilibrium process. If number of moles are unequal in chemical reaction, that is pressure is affected according to Lee-Chatelier principle. Next one, catalyst is a substance that increases the rate of reaction not involved in the chemical reaction. So, it is given. So, catalyst is any reaction is involved. So, then rate of reaction is increases without involved in chemical reaction, that is known as catalyst. So, it is given. First one, Lee-Chatelier principle definition is completed. Factors also completed. Effect of concentration, effect of temperature, effect of pressure, effect of catalyst. Increases the concentration of reactant or decreases the concentration of product for forward reaction is takes place, opposite backward reaction. Next one, effect of temperature. Temperature is increases and endothermic. Temperature is decreases, exothermic reaction is takes place. Next one, effect of pressure. Pressure is not affected when chemical reaction number of moles are equal, reactant and product. In reactant and product side, number of moles are unequal, then pressure is affected. Pressure is increases, number of moles are decreases. Pressure is decreases, number of moles are increases. నెక్స్ట్ వన్ ఎఫెక్ట్ ఆఫ్ క్యాటలిస్ట్. క్యాటలిస్ట్ అనేది రియాక్షన్లో ఇన్వాల్వ్ కాదు, రియాక్షన్ యొక్క రేట్ని ఇంక్రీజ్ చేస్తుంది. సో ఇన్ కెమికల్ రియాక్షన్, సో హేబర్స్ ప్రాసెస్ ఐరన్ క్యాటలిస్ట్, ఆస్ట్వాల్డ్ ప్రాసెస్ ప్లాటినం క్యాటలిస్ట్, కాంటాక్ట్ ప్రాసెస్ V2O5 క్యాటలిస్ట్. సో దిస్ ఈస్ ద ఫస్ట్ వన్ స్టూడెంట్స్, లీ చాట్లియర్ ప్రిన్సిపల్ అండ్ ఫ్యాక్టర్స్ ఇన్ఫ్లుయెన్సింగ్ ఆఫ్ ఈక్విలిబ్రియం ప్రాసెస్. Next one, discuss the applications of Lee Chartier principle, industrial synthesis of ammonia and sulfur trioxide. First one, industrial synthesis of ammonia. Industrial synthesis of ammonia. Ammonia formula NH3. Next one, industrial synthesis of SO3 means sulfur trioxide. So this is given. This process is known as Haber's process. Next one, this process is known as contact process. So students, this is difference is known. This answer is very simple. So equation is taken N2 plus 3H2 formation of 2NH3 delta H equal to minus 92 kilojoules. So students, హేబర్స్ ప్రాసెస్ ద్వారా అమోనియా తయారు చేస్తాం. హేబర్స్ ప్రాసెస్ ద్వారా అమోనియా తయారు చేయాలంటే ఐరన్ అనేది క్యాటలిస్ట్గా ఉంటుంది, మాలిబ్డినం అనేది ప్రమోటర్గా ఉంటుంది. క్యాటలిస్ట్ అనేది రియాక్షన్లో ఇన్వాల్వ్ కాదు, కానీ రియాక్షన్ యొక్క రేట్ని ఇంక్రీజ్ చేస్తుంది. రియాక్షన్లో ఇన్వాల్వ్ కాకుండా రియాక్షన్ యొక్క రేటును ఇంక్రీజ్ చేసే సబ్స్టెన్స్ని క్యాటలిస్ట్ అంటారు. సో ఇట్ ఈస్ గివెన్. సో దిస్ ఈజ్ హేబర్స్ ప్రాసెస్. హేబర్స్ ప్రాసెస్ ద్వారా అమోనియా తయారు చేస్తాం. కాంటాక్ట్ ప్రాసెస్ ద్వారా సల్ఫ్యూరిక్ యాసిడ్ తయారవుతుంది. సో ఈక్వేషన్ ఈజ్ గివెన్ N2 plus 3H2 formation of 2NH3. So this is minus. Minus means this is exothermic reaction. So next one, effect of concentration. Increases the concentration of reactant, decreases the concentration of product. This is formation of ammonia takes place. So it is given. So effect of concentration is observed. So next one, increases the concentration of reactant. Concentration of reactant decreases the concentration of product. Concentration of product. Formation of ammonia takes place. Simple. Formation of ammonia takes place. So students, this is effect of concentration. Effect of concentration. Next one, effect of temperature is observed. Minus means exothermic. Exothermic reactions are low temperature is favorable, but at low temperature reaction is slow. So optimum temperature is maintained 725 to 775 Kelvin temperature. So it is observed temperature 725 to 775 Kelvin temperature. According to Lee Chartier principle, exothermic reactions also containing low temperature. So it is observed at low temperature reaction is slow. So optimum temperature is maintained exactly 725 to 775 Kelvin temperature. This is temperature is most important. Next one, so it is given, pressure is given exactly 200 atmospheric pressure. Iron acts as catalyst molybdenum acts as promoter. Molybdenum promoter. So students, so in this reaction, number of moles are decreases from left to right. This is 4 number of moles. This is 2 number of moles. Number of moles are decreases from left to right. So pressure is increases. Exact pressure formation of ammonia 200 atmospheric pressure. In this reaction, ammonia formation, iron acts as catalyst, molybdenum acts as promoter. సో ఐరన్ అనేది క్యాటలిస్ట్ గా యాక్ట్ అవుతుంది. ప్రమోటర్ అనేది ఇంక్రీజెస్ ద యాక్టివిటీ ఆఫ్ క్యాటలిస్ట్ ఈజ్ నోన్ యాజ్ ప్రమోటర్. అకార్డింగ్ టు లీ చాట్లియర్ ప్రిన్సిపల్, ఫార్మేషన్ ఆఫ్ అమోనియా ఈజ్ ఏబర్స్ ప్రాసెస్. ఏబర్స్ ప్రాసెస్ ద్వారా అమోనియా తయారు చేయాలంటే ఐరన్ క్యాటలిస్ట్ గా ఉంటుంది, మాలిబ్డినం ప్రమోటర్ గా యాక్ట్ అవుతుంది. ప్రమోటర్ మీనింగ్ ఇంక్రీజెస్ ద యాక్టివిటీ ఆఫ్ క్యాటలిస్ట్ ఈజ్ నోన్ యాజ్ ప్రమోటర్. So students, this sentence is equation is important. Temperature 725 to 775. According to Le Chatelier principle, number of it is minus means exothermic. Exothermic reactions always containing low temperature. At low temperature reaction is slow. So optimum temperature is maintained 725 to 775 Kelvin. Next one, number of moles are decreases from left to right. So pressure is increases. Exact pressure 200 atmospheric pressure. So in this reaction, iron acts as catalyst, molybdenum acts as promoter. Next one, industrial synthesis of SO3 is observed. 2SO2 plus O2, formation of 2SO3, delta H equal to minus 189 kilojoules. So next one, it is given V2O5 acts as catalyst. Next one, it is 1.5 to 1.7 atmospheric pressure. Next one, in this observation part, according to Le Chatelier principle, this is effect of concentration, formation of SO3. It is increases the concentration of reactant or decreases the concentration of product, SO3 formation. Next one, effect of temperature means it is also minus. Minus means exothermic. According to Le Chatelier principle, exothermic reactions always containing low temperature. At low temperature, reaction is slow. So optimum temperature is maintained. The temperature 673 Kelvin temperature. Next one, in this process, vanadium pentoxide acts as catalyst. Pressure range is 1.5 to 1.7 atmospheric pressure. Haber's process, ammonia prepared. Contact process, SO3. Next, last step, sulfuric acid also prepared. Next one, Haber's process, iron catalyst. Contact process, V2O5 catalyst. Haber's process, temperature 725 to 775 Kelvin. Contact process 1.5 to 1.7 atmospheric pressure. Haber's process, promoter is molybdenum. Contact process, no promoter. Only next rate of reaction is increases, no promoter, only catalyst is vanadium pentoxide. So students, this is total Haber's process for the preparation of ammonia. This is contact process for the preparation of sulfur trioxide. This is very, very important answer, IP orientation. Next one, what is the concept of Bronsted acid and Bronsted base? What is Bronsted acid? What is Bronsted base? Bronsted acid is observed. This is given Bronsted acid. Bronsted acid means proton donor is known as Bronsted acid. Proton donor is known as Bronsted acid. So, which is donate the proton, that is known as proton donor. Proton donor is known as Bronsted acid. Next one, Bronsted base is taken. Bronsted base. Proton acceptor is known as Bronsted base. Proton acceptor is observed, that is known as H plus 1 proton. It is given H2O gaining of 1 electron, that is 1 proton, that is H3O. So proton acceptor is known as Bronsted base. Proton donor is known as Brownsted acid. HCl donate the one proton, so HCl it is converted into Cl minus. So HCl donate the one proton, that is acts as a Brownsted acid. Brownsted base means proton acceptor. H2O gaining of one proton, so H2O is converted into H3O plus. This is acts as that is a Brownsted base concept. So it is given different types of example. Next one, it is also important, Lewis acid. Lewis acid means electron pair acceptor. Electron pair acceptor is known as Lewis acid. For example, electron pair acceptor BCl3, BF3. Next one, it is gain of one pair, one electron pair acceptor, that is known as Lewis acid theory. Next one, another one, Lewis base is taken. Lewis base means electron pair donor. Electron pair donor. For example, it is taken ammonia. Ammonia donate the one lone pair. Extra one lone pair is present. H2O, it is also two lone pair present. HF is taken, three lone pairs are present. So Brownsted acid means proton donor is known as Brownsted acid. Proton donor is known as Brownsted acid. So it is given NH3 plus H2O, NH4 plus OH minus. So which compound is donate the proton, that is acts as Brownsted acid. Which substance is accept the proton, that is known as proton acceptor. HCl donate the proton, HCl is converted into Cl minus. H2O accept the proton, it is converted into H3O plus. So which substance is donate the proton, that is Brownsted acid. Which substances accept the proton, that is known as Brownsted base. It is the conjugated acid base theory also present. Conjugated acid base theory also very important definition. The acid base theory, it is differ by single proton, that is known as conjugated acid base theory. So conjugated acid base theory observed NH3 plus H2O, NH4 plus OH minus. So in this observation part, conjugated acid base theory means the acid base theory which differ by single proton, that is known as conjugated acid base theory. Every definition also very important, students. Next one, this is total all very important answer. Lee Chatelier principle, most important answer. Preparation of ammonia, Haber's process. Preparation of next SO3, that is contact process, students. So students, next explanation part, fourth one, N2 plus 3H2 formation of 2NH3 and 2SO2 plus O2 formation of 2SO3. First one, Haber's process, ammonia preparation. Next one, contact process, sulfuric acid preparation. So it is given Kp, Kc is observed. Next one, it is observation part, Kp, Kc. Kp equal to Kc into R to the 4 of delta N. Next one, delta N equal to change in number of moles. Change in number of moles, that equal to delta N equal to product number of moles minus next product number of moles and reactant number of moles. So it is observed Np minus Nr. So observation part, first equation N2 plus 3H2 formation of 2NH3, that is Haber's process, delta H minus 46.1 or minus 92 kilojoules. So it is given, this is 1 mole, this is 2 moles, this is 4 moles. Reactant side 4 mole, product side 2 moles. This is substituted, delta N equal to product observed 2, reactant equal to 4, that equal to minus 2. So students, delta N value negative, delta N equal to 0, Kp equal to Kc. Next one, delta N equal to negative, then Kp, this is greater than K, it is Kp less than Kc. If delta N equal to positive, Kp greater than Kc. This is no. So it is these two equations are very simple. So it is observed delta n value negative. Delta n is observed to -2. So 10 plus 3h2 observed Kp, it is less than Kc. This is equation. Next one, 2SO2 plus O2 observed delta n change in number of moles Np minus Nr. Np2 is taken, Nr3 is taken, equal to -1. Delta n negative is observed, Kp, it is also Kp less than Kc. So students, delta n means change in number of moles. N2 plus 3H2 formation of 2NH3, 2SO2 plus O2 formation of 2SO3. Both are, it is delta n value negative, so Kp is less than Kc. Products are less number of moles compared to reactant. So it is N2 plus 3H2 formation of 2NH3. Next one, 2SO2 plus O2 formation of 2SO3. Both are Kp less than Kc. This is 4 moles, this is 2 moles, this is 3 moles, this is 2 moles. So students, fourth one is complete. Next one, fifth one, what is buffer solution? The solution which resists the solution which resist the change in pH value, change in pH value, change in pH value by the addition of acid and base, strong acid and strong base. So what is buffer solution? The solution which resists the change in pH value by the addition of strong acid and strong base, that is known as buffer solution. So it is buffer solution is observed. Two types of buffer solution is observed. One is acidic buffer solution. Acidic buffer solution. Next one, second one is a basic buffer solution. Basic buffer solution. So it is given weak acid plus salt of strong base. Next one, weak base plus salt of strong acid. So students, so weak acid is taken CH3COOH plus CH3COONA. Best example for acidic buffer solution. So weak base NH4OH, next salt of strong acid NH4Cl, NH4, this is NH4OH. So students, this is taken NH4. So NH4OH plus NH4Cl, ammonium hydroxide, ammonium chloride, best example for basic buffer solution. What is buffer solution? The solution which resists the change in pH value by the addition of strong acid and strong base, that is known as a buffer solution. So buffer solution explanation part, two types of buffer solutions are important. Acidic buffer solution and basic buffer solution also important. So this is up to this part is important part. So next one, so pH already known formula, pH equal to pK, it is given. So pH plus pOH equal to 14, pH equal to minus log H plus concentration also given. So next one, so students, next one, explanation part, fifth one, define pH, explain buffer solution. pH means negative logarithm of hydrogen ion concentration is known as pH. So it is given pH definition, negative logarithm of hydrogen ion concentration is known as hydrogen ion concentration is known as pH. So it is given pH equal to minus log H plus concentration. So that is pH. So next one, buffer solution. What is buffer solution? So the solution which resists the change in pH value, by the addition of strong acid and strong base. So students, buffer solution mean the solution which resists the change in pH value by the addition of strong acid and strong base. So this buffer solution classification also important. Two types of buffer solutions are present. First one, acidic buffer solution. Next one, basic buffer solution. So students, acidic buffer solution means weak acid. It is taken weak acid plus salt of strong base. That is example is given CH3COOH plus CH3COONA. Best example for acidic buffer solution. Basic buffer solution, NH4OH plus NH4Cl. This definition, weak base plus salt of strong acid. This is example for basic buffer solution. So pH means negative logarithm of hydrogen ion concentration. pH equal to minus log 10 H plus concentration. Buffer solution means the solution which resists the change in pH value by the addition of strong acid and strong base. Buffer solutions are two types: acidic buffer solution, basic buffer solution. Acidic buffer solution means so weak acid plus salt of strong base. Basic buffer solution, weak base plus salt of strong acid. CH3COOH plus CH3COONA. Best example for acidic buffer solution. Next one, NH4OH plus NH4Cl. Best example for this is basic buffer solution. So students, next one explanation. What are electron deficient compound? Electron deficient compound means less than 8 electron to the formation of it is covalent bond. It is less than 8 electron, that is 13th group elements are acts as electron deficient compound. So what is electron deficient compound means less than 8 electron for the formation of covalent bond, that is known as electron deficient compound. Just like it is taken 13th group elements are acts as electron deficient compound. Deficient compounds. So students, 13th group means boron family elements, that is acts as electron deficient compound less than 8 electron to the formation of Lewis dot structure, that is known as electron deficient compound. So it is observed BF3 is taken. BF3 structure is observed B. This is fluorine. So three bonds equal to only 6 electron. So student, each bond containing 2 electron, 3 bonds equal to 6 electron, less than 8 electron. So this compound is known as electron deficient compound. So it is given BCl3 is Lewis acid. Why? So it is observed BF3 zero lone pair. It is observed zero lone pair. Already, so 3 covalent bonds are present, no lone pairs, sp2 hybridization. So Lewis acid means electron pair acceptor is known as Lewis acid. Electron pair acceptor. So this is 6 electrons are present, 6 electrons are converted into 8 electron, 1 electron pair is observed. So BF3 acts as Lewis acid. BF3 లో 6 electrons ఉండడం వల్ల ఇది 2 ఎలక్ట్రాన్ గెయిన్ చేసే నేచర్ వల్ల BF3 అనేది లూయిస్ యాసిడ్ గా కన్సిడర్ అవుతుంది. అసలు లూయిస్ యాసిడ్ మీనింగ్, లూయిస్ యాసిడ్ మీన్ ఎలక్ట్రాన్ పేర్ యాక్సెప్టార్ ఈజ్ నోన్ యాజ్ లూయిస్ యాసిడ్. So this is octant rule explanation part. 6 electrons are converted into 8 electron, 2 electrons are less, gaining of 1 lone pair. So BF3 acts as Lewis acid nature. So student, electron deficient compound definition is completed. BF3, why BF3 Lewis acid is completed? Because BF3 6 electron less than 8 electron. This is exhibit octant configuration. So that is noble gaseous configuration. So 2 electrons are gaining. So that is acts as Lewis acid. Lewis acid means electron pair acceptor. Electron pair acceptor is known as Lewis acid. So students, these sentences are very, very important IP orientation. Define ionic product of water. Simple. The product of H plus concentration and OH minus concentration. Concentration indicated to square bracket. So it is given Kw equal to H plus concentration and OH minus concentration. H plus 1 into 10 to the power of minus 7. OH minus also 1 into 10 to the power of minus 7. So final 1 into 10 to the power of minus 14. So it is given next one this value. So 1 into total 10 to the power of minus 14 mole square per liter square. So room temperature value Kw H plus and OH minus. This is 2 marks. What is ionic product of water? The product of H plus ion concentration and OH minus ion concentration, that is known as ionic product of water. It is denoted with Kw. Kw equal to H plus concentration and OH minus concentration. This value 1 into 10 to the power of minus 14 mole square per liter square at room temperature values. So given what is Arrhenius acid? Eighth one, it is given Arrhenius acid. Arrhenius acid means the substance dissolved in water. The substance dissolved in water to produce H plus ions. Which compounds are dissolved in water, produce H plus ion, that is acts as Arrhenius acid. For example, HCl, example HNO3, hydrochloric acid, nitric acid, sulfuric acid, these all are Arrhenius acid. So student, Arrhenius acid means the compounds are dissolved in water to produce H plus ions, that is known as Arrhenius acid. Example, hydrochloric acid, nitric acid, sulfuric acid, all are explanation of Arrhenius acid concept. Next one, what is Arrhenius base? So given Arrhenius base means the substance dissolved in water, the substance dissolved in water to give OH minus ions. So student, ఏ సబ్స్టెన్స్ అయితే వాటర్లో డిజాల్వ్ అయి OH మైనస్ అయాన్ని ప్రొడ్యూస్ చేస్తాయో దాన్ని అరీనియస్ బేస్ అంటాము. ఏ సబ్స్టెన్స్ అయితే వాటర్లో డిజాల్వ్ అయి H ప్లస్ అయాన్లను ప్రొడ్యూస్ చేస్తాయో దాన్ని అరీనియస్ యాసిడ్ అంటాం. ఎగ్జాంపుల్ అరీనియస్ బేస్ సోడియం హైడ్రాక్సైడ్, పొటాషియం హైడ్రాక్సైడ్, calcium hydroxide, all are example for Arrhenius base. Next one, neutralization reaction also important. What is neutralization reaction? Neutralization reaction mean acid plus base gives salt plus water. This is a neutralization reaction. So student, Arrhenius acid definition is completed. Arrhenius base definition is completed. Example also completed. Neutralization reaction, acid plus base gives salt plus water. This is Arrhenius acid base concept. Next one students, it is Arrhenius acid base theory. Next one, it is Le-Chatelier principle, Bronsted acid base theory, Lewis acid base theory. Next one, it is a buffer solution. These all answers are practice students. So students, next explanation part, VSAQs, chemical equilibrium, acids and bases. So first one, what is homogeneous equilibrium? So homogeneous equilibrium means reactant and catalyst both are same physicals. It is given reactant and products also. Reactant and product, that is given product, both are same physical state. Reactant and product both are same physical state is known as homogeneous equilibrium. For example, N2 plus 3H2, formation of 2NH3. This is also gas, this is also gas, this is also gas. Reactant gaseous, product gaseous, that is known as homogeneous equilibrium. So next one, it is given 2SO2 plus O2, formation of 2SO3 is observed. This is also gas, this is also gas, this is also gas. So student, reactant and catalyst both are same physical state, that is known as homogeneous equilibrium. Two examples, this is two example. Reactant also gas, product also gas. Reactant also gas, product also gas. So that is known as homogeneous equilibrium. So students, first one, homogeneous equilibrium is completed. Next one, heterogeneous equilibrium, very simple. Opposite of homogeneous equilibrium, reactant and product, both are different physical state. Different physical state is known as heterogeneous equilibrium. So given, so it is given heterogeneous equilibrium, reactant and product both are different physical state is given, that is known as heterogeneous equilibrium. So homogeneous equilibrium, reactant catalyst both are same physical state, but heterogeneous equilibrium given CaCO3 observation part, CaCO3. So CaCO3 is observed, CaO plus CO2. So given CaCO3 is solid, CaO solid, CO2 gas. Different physical state, MgCO3 also taken, MgO plus CO2. So this is observed, this is solid, this is solid, this is gas. So different physical states of product and reactant, that is known as heterogeneous equilibrium. Limestone is converted into quicklime and CO2, and magnesium MgCO3 also converted into MgO plus CO2. These two examples are example for heterogeneous reaction. This is definition students. This is chemical reactions. Next one, what is the relation between Kp and Kc? Kp equal to Kc into r to the power of delta n. So where delta n equal to negative, Kp less than Kc, where delta n equal to positive, Kp greater than Kc, where delta n equal to 0, then Kp equal to Kc. So delta n means change in number of moles. This is Kp Kc relation and derivation part. Next one, chemical reaction Kp equal to Kc, H2 plus I2 is taken 2 Hi. Then so it is a reactant side 2 moles, product side 2 moles. Then Kp equal to Kc. Next one, N2 plus O2, formation of 2NO also taken. This is 1 mole, this is 1 mole, this is 2 mole. Reactant side 2 mole, product side 2 moles, then Kp equal to Kc. This is a Kp Kc equation, equilibrium reaction. What is conjugated acid-base theory? The acid-base theory which differ by single proton, that is known as conjugated acid base theory. So it is given NH3, it is given plus H2O, formation of NH4 plus plus OH minus, best example for conjugated acid base theory. So this is differ by one proton, this is differ by one proton, that is known as conjugated acid base theory. The acid base theory which differ by single proton is known as conjugated acid base theory. So it is given this difference is one proton, this difference is one proton. So this is acts as conjugated acid base theory concept. Next one, what is the value of Kw? Kw means ionic product of water, 1 into 10 to the power of minus 14 mole square. Next one, liter. Next one, this is ionic product of water. What is ionic product of water? The product of H plus ion concentration and OH minus ion concentration. This is Kw. Next one, it is units. Next units and values also completed. Next one, simple pH equal to next BaOH2 observation, Ba plus 2 OH minus, already OH minus concentration is given. So 2 into 0.05, that equal to 0.1 equal to 10 to the power of minus 1 also taken. POH equal to minus log OH minus ion concentration. So that equal to minus log 0.1, that equal to 10 to the power of minus 1 log 10, that equal to POH equal to 1. So students, pH plus POH equal to 14. Then pH equal to, so it is 14 minus 1, that equal to 13 answer. This is 13 students. This is this answer is 13th answer. Next one, pH 0.1, pH equal to minus log H plus ion concentration, already 0.1 equal to given, equal to minus log 0.1, that equal to 10 to the power of minus 1. So pH equal to 1. This is 0.1 m hydrochloric acid solution. Next one, Lewis acid. What is Lewis acid? So Lewis acid means electron pair acceptor is known as Lewis acid. Electron pair acceptor is known as Lewis acid. So example, electron pair acceptor, that is BCl3, example BF3. Next one, Lewis base is taken, electron pair donor is known as Lewis base, example ammonia, best example, water, best example. So Lewis acid mean electron pair acceptor, Lewis base mean electron pair donor. So definition and examples are very, very important. So Brownsted base, proton donor is called Brownsted acid, proton acceptor. So proton acceptor is known as Brownsted base, best example OH minus. So what is Brownsted acid? Proton donor is known as Brownsted acid. Proton acceptor is known as Brownsted base, OH minus gaining of 1H plus, then H2O is formation. OH minus is best example for Brownsted base. Next one, Kp greater than Kc given. So it is 2 KClO3 is taken, 2 KCl plus 3O2. So observation, this is 2, this is 2 plus 3, 5. So Kp is less, it is greater than Kc. So student, this is a Kp-Kc relation. Potassium perchlorate converted into KCl plus 3O2. Product is more, reactant is less. Then delta N value positive. Then Kp is greater than Kc. So dynamic equilibrium definition. The rate of forward reaction and backward reaction is complete same. So what is dynamic equilibrium? That equilibrium at which rate of forward reaction is equal to rate of backward reaction. The equilibrium at which rate of forward reaction is equal to rate of backward reaction. This is known as dynamic equilibrium concept. So the equilibrium in which rate of forward reaction is equal to rate of backward reaction, that is known as dynamic equilibrium concept. So students, this is dynamic equilibrium concept. Next one, BF3 is absorbed Lewis acid. BF3, 3 bonds equal to 6 electron, less than 8 electron. So 1 electron pair is converted, it is 6 electron is converted to 8 electron. 1 electron pair acceptor. So this is acts as Lewis acid. 1 electron pair acceptor. So this is acts as Brown's, it is Lewis acid. So students, Lewis acid mean electron pair acceptor. Lewis base mean electron pair donor. BF3 gain of 1 lone pair. 6 electron is converted into 8 electron octet rule, that is stable. So it is BF3 acts as it is Lewis acid concept. So students, so chemical equilibrium, acids, bases, 2 marks are practice. So 4 marks and 2 marks this topic weightage, 4 and 2 marks are practice. So students, thank you.